For our last function, we're going to be looking at writing something a bit more advanced over here. So let's go ahead and write ourselves a distance function. So in other words, given an x and a y, and this will have to be a double because of just the way the distance function will work. So we're going to return a double, and it's going to be called the distance function. And it will give me the distance between this object. Okay, so this object, which will be, say, whatever, and another point P. So returns the distance between this point and another point called P. All right, so for those of you who don't remember, the distance is equal to the square root of the difference between the x's squared and the differences between the y squared. And I totally didn't have to look that up, nor did I have to look it up every single other time I've done this because, right, I totally had to look it up every single time I've done this. So anyway, let's go ahead and quash this error, return -1, right? So what we need to do is calculate the difference between the x's. Dx is equal to, so let's create a int dx, and that will be the difference between the x's, and int dy, which will be the difference in the y's, and then we'll need a double distance, or yeah, why don't we call it distance? Okay, so dx is equal to the difference between the x's. So in other words, it's equal to this dot x minus p dot x, right? That's this point minus that point's x. And dy is similar, this y rather, minus p dot y, right? So I'm taking mine, I'm subtracting the x's, I'm taking my y and subtracting their y from it. Why am I using this and p, right? Because again, what we've defined this distance function to be is, this is an instance function. So it is going to be a specific point that runs this function. So that point is going to run this code and say, my x minus their x, my y minus their y. So double distance is equal to, as I mentioned, the square root of the differences squared. So math.square root, right? So the math function is again that library that has all those useful things. Math.pow dx2. So what is pow? Pow is the way you do exponents in Java, right? This is the base, this is the exponent, so this is saying dx squared raised to the second power, plus math.pow dx2, or rather dy2. And then we return the square root of that sum. So math.square root. All right. So now we return, and now instead of returning distance, we can just simply return this straight out. Okay. So let's take a look at that and say, let's go ahead and make a new point. So I'm going to leave 0, 0 out there, and I'm going to use p4 is equal to point. P4 is equal to new point three, 4. So if this should have a distance between that and 0, 0 of, let's see, 5, I would think. Let's go ahead and see that. P4. So what we're going to do over here is we are going to print out P4 dot distance to P3. And that's 5.0, right? Because of the properties of, right? We've got a point at 0, 0, right? So we have a point at 0, 0. We have a point at 3. Let's go ahead and actually you know what? Draw that out in a very ASCII-ish fashion, right? So we've got 1, 2, 3, 4. Let's go ahead and do this with O's. Okay, so we have ourselves a point at 0, 0, right? So I suppose I need 6 on each of these, right? Let this be 0, 0 over here. So we have a point here at 1. So we have a point at 0, 0 and a point at 3, 4. 0, 1, 2, 3. Then 0, 1, 2, 3, 4. Right? And the difference between those, right, is if we construct it like, say, and notice what I've constructed over here are two sides of a 3, 4, 5 triangle. Right? So the diagonal would be 5 distance. And this doesn't show up too well because, of course, it is I'm doing this in ASCII and it's, rectangular. Notice the cursor is rectangular. It's not using a square space. But it hopefully gets the point across without me, pulling out my terrible MS Paint skills. Plenty of time for that later. So, but that makes sense. The distance between those 2 points should be 5. We can use it on. Let's try it on a bit of an easier mathematical point, right? Same x and 10. So the distance should be between those should be 10, and it is, right? So, right, they're on the same x. They have the same x coordinate, which means they're both on the y line. Both on the same. They're both on basically this vertical line. So this works out. So this distance function works out. And notice that it's asking for the distance between P4 and P3. It's P4 saying, what's the distance to me? And of course, because of the properties of the distance function, not because of any way we wrote this, but because of the way the distance function, the Euclidean distance function works, it's completely reversible. Now, we contrast this with maybe a static method, and more on that later. A static method, public static double distance. Now, all right, so a couple things are going to go on over here. Point P1, point P2. Now, what a static method does is that static methods don't belong to any particular instance of a class. In fact, if you have a particular instance call a static method, it will tell you, hey, this belongs to a class variable. Or rather, this belongs to the class, and you should refer to it in static context, whatever that means. Right? What it's saying is that basically we'll use it as point.distance. We'll see how that works later. But the difference between a static method and an instance method is that there is no this in a static. There is no singular point to refer to. There is no implied this. So any points that you're going to use are going to need to be taken in as parameters. That may not make sense. It will make more sense when we cover circles and go over the static variable. But suffice to say, this has a this. And if I try to use this over here, this.x, it's going to give me an error saying that static methods don't even have a this. Right? There's no this for this to refer to. But this works out the same way. The only difference is that we will be doing this P1, P1, and P2, P2. Okay, and now if we go over here to point driver Sout, we're not going to say P. Let's go ahead and do this again. We're not going to say P3 dot distance P3 P4. It's kind of redundant to do that, and it's not necessarily the best. It says accessed via instance reference, static member reference that way. Instead, the way we will use static methods, as we'll see, is to use it like this. The point class takes in two distance objects. And this is useful, say, if you wanted to use basically points that we didn't even have a reference for. That's totally a legal move right over here. that will create a new point on the origin, so its answer should also be 10, right? But anyway, that's all I have about points. That's enough to confuse you with for right now. We'll go over more on the static later, so it's not imperative that you understand it now, but understand what instance methods are.